I've known Cathy for many, many years. She's worked at some of the really sort of big material groups in Western Australia, like Concord Engineering with the ceramic development, and Bradken as product development manager, and then over future past that into Newcastle as extra work over there. So let's give a welcome to Cathy and great talk.
I've spent the last 3 years at Davies WearPlate Systems, and so instead of talking about the materials of the wear liners, we're now going to talk about how we attach them to the chute walls. And just in the last 3 months, Davies has been acquired by Metso Outertech. So we're the little third party. Metso Outertech are the ginormous two that are merging together, and we're the little baby third party on the side. So that's been lots of fun, but this is what I actually enjoy, is the material side of things. So Davies WearPlate Systems, and I'll keep calling it that because it's business as usual until we're fully integrated, okay? So we've got two main arms, and today I really want to talk to you about the second arm, but I'll give you a first overview of the WearPlate Systems side of things, which is where Brian and Davies WearPlate Systems actually started. We have a couple of attachment types, actually 3 different attachment types, and all of the handling and lifting equipment that goes with that. The attachment types are different in that they're wear side only attachment types. So you apply and undo from the wear side only. So that instantly means that you only need to scaffold the inside of the chute. You don't need to access the outside of the chute. So that instantly saves you time. You don't need as much labour because you don't need a person on the outside going, yes, I've put the bolt through, now you can attach the nut. You need just the person on the inside. We've also strived to make them as simple as possible, so it is much faster than the standard nut and bolt. Just in the past few years, we've been developing this whole side of the business, which we're calling WearSense, and that's our condition monitoring arm. So we'll get to that a bit later in the presentation. So firstly, just to give you a quick overview of the WearPlate systems in case you haven't been exposed to them before. The main attachments that we have are the, oops, sorry, wrong one, the taper T. Where'd my buzzer go? It's gone. Oh, there it is. So the taper T, and it's called taper T because it just has a T-shaped nut. This is installed with this tooling down here, so it's just a 3-pronged on a normal impact wrench. Drive it in, the T engages and rattles up and clamps onto the liner. All of these attachment systems use a tapered hole in the liner, and we really try to match the wear resistance of this head in all of the applications to the properties of the liner. So we're really trying to give you that smooth surface because we know that any hang-ups or gaps or areas of different material really create wear problems, create wear tracking, and that's when you lose life. So the first attachment actually, so that was the taper T. The next one is the Easy Lock, and so that's for thicker liners where you've got a bit more weight and where you need to maintain that clamping force. And it's a very simple, we contain 3 ball bearings in a sleeve. We drive a pin down through the ball bearings. The ball bearings pop out at the back of the chute, and that actually clamps it onto the wall. And then to get it off, you just poke the pin through it. It's contained in this housing at the back, so nothing drops off. The ball bearings fall in, and you can take the bolt out the front. These attachments will work with any liner material. We've even used the ceramic one in the middle here. So all we have is quite a small hole in the front face of the ceramic, again, because you don't want to interrupt that entire wear face. We also do have 2-sided attachments. And because we're using 12.9 grade bolts in them, we can reduce the bolting intensity. And so we're reducing bolting intensity, which reduces time to install. We have the entire safe fit handling system. Because we use the tapered hole in the liner, we then need lifting equipment. We're not welding anything to the liner. we're just using these simple scissor clips that fit in the hole. We can move it onto the wall. We can then use the clamp, which sits through the chute wall, clamps the liner to the wall. We can fill in the rest of the bolts and then remove the clamp. We've also got some ease of use podgy bars just to move the liners around, inch them around so that we get them in the exact right spot. And also we supply all of the tooling that goes with that. So that's just a quick overview. There's reasons why you'd use different bolts in different applications, and the BD guys can certainly help with that if you have any questions. So the Easy Lock, as I was explaining, it's a simple 3 balls contained by the sleeve. The pin pops down the middle. We use a air over hydraulic pump just to pump that pin to the exact spot that we want it. Pops the balls out, as you can see behind the chute wall, and it sits the bolt in the liner. So it gives us really, it's recommended for liners that are that bit thicker, like I said, 32 mil, and it gives us really nice clamping forces. We've done a lot of engineering and understanding around those clamping forces because we've got angles and different forces and ball bearings and trying to actually calculate that clamping force and say, yes, it's the same as a 12.9 bolt is actually quite tricky, but we have done a lot of work around that so that we're satisfying ourselves and as well as our customers. So the Easy Lock tooling, very simple. We attach it to the front of the bolt. We attach the little locking pin in the front, and it just drives that locking pin to the correct location. We use a very simple pneumatic jackhammer with a specially designed tool just to, from the front, poke that pin through, and it's as simple as that. The beauty of the Easy Lock is it doesn't need to turn in the hole. So any corrosion that you get, if it's a long lifetime, it doesn't need to turn at all. You don't actually need to physically undo it. The taper T, on the other hand, actually does need to turn, and that's one of the reasons why we have this this gribby fuchsia, this gribby fuchsia cap. But it's a much simpler tooling system, so we've just got the one baby tool, and any battery-operated impact drill will drive that. So again, very simple. This uses a slot in the wall, and we just turn the T across the slot and then rattle up to actually gain our clamping force. And again, because it's a bit slighter, we use this for liners usually up to about 32 mil thick. Again, taper T tooling, we can retrofit. Brian is amazing at coming up with groovy ideas, he really is, and part of making this useful, because not all new chutes have slots, we don't always get the opportunity to make a chute from scratch. How do we retrofit into the slots? So he's designed this plasma cutting machine which will cut the exact size slot that we need in your wall. Ceramic taper Ts. You can see from this one that there's a very small hole. We use a hex drive just to activate the T, so it's a similar idea as the taper T, but it actually, and you can see that here, just turns and rattles up and holds it on. And so that's your standard ceramic liner, which is quite prevalent in the Pilbara these days. The rem lock, for our two-sided attachments, the way we overcome some of the corrosion issues that we've been talking about this morning is actually, we've designed this prevailing torque lock nut, which combines the nut, so it's a class 12 nut, as well as the sleeve, if you like. So we've got our plastic sleeve that sits over, protects the threads, and at the end of life you can just come along and undo it. It's fantastic. It really took off after that conveyor fire up north too. So we've had quite a lot of trials after that, because that was hot works cutting off nuts that set that conveyor belt on fire. So these have quite taken off, and we'll make those on any sizes upwards of M16. The taper lock and the D-lock, they're, again, this was the grade 12.9 countersunk bolt, and that gives you the ability to have reduced bolting intensity. The reason that we've gone forward with this D-lock, we've just lopped off one of the sides. when you're installing this, you actually need to put a hex Allen key in it to hold it to stop it moving while the guy on the back rattles up the nut. So there's a lot of issues there with repetitive strain injury. We were getting a lot of issues. So we've designed now this new head which will lock it in place, and all you really need to do is just hold it there while the nut's rattled up. So the ideal for this would be the D-lock in association with the rem lock to protect the nuts while it's there. Protect the threads while it's there, sorry. The safe fit handling system I sort of had a bit of a chat about. So we've got the lifting clips, and they're 1 tonne working load limit. So we've had those engineering, third-party rated, all the things that you need to do for lifting equipment. We've got clamping tools that work with both the slot and the round hole for the easy lock. We've also got lifting equipment that works with the ceramic liners, because as the ceramic liners go from 300 by 300, which a person can lift, and they get larger and larger, we need mechanical aids to actually help us get them on the wall. So we've designed all of that equipment around our liners and our attachments. So the groovy part of the talk, the WearSense part. This, initially it was discussed as it would fit on the back of a taper tee. So it had to fit through the slot. It had to be operated from the front, the wear side only, and it's a condition monitoring. So it's a wireless plug and play. It talks to the cloud, and the cloud talks to us, and it all happens, the IT people tell me. So we actually have expanded on it for use outside of those applications that aren't currently using Davies taper tee, and we're calling those the hugger. Long story, cut very short, the whole alien face hugger, that's where we got the name from. So that was our initial design, was that actual alien on front, but it looked a bit dodgy in 3D. So we've got the huggers, and they can work on any application, including pipe work. We need gateway and a receiver, so I'll go into a bit more information. We've got some really groovy analytics in behind the sensor data. We're analysing the sensor data, and we're giving you not only what it's exactly reading, but forecasting where you're likely to be. So this is the first example. This is a train loadout chute that, so the train carriages come in under here, and it swings and loads them all up. So what we have here is little sensors on the outside that look like this. We have a receiver on this side and a receiver on that side, because obviously one of the initial things that we do when we go to a site or an application is check the radio, the receiving all the way around your application, and where we're going to put our receivers. We then have the gateway that talks to the cloud. You have your user interface, so you can see in real time what the sensors are actually showing you. So that's just discussing the two form factors, and that it's a glass-filled nylon housing, just for durability. But the main thing is we can have the short, stubby hug into the surface, or the more protruding WearSense for taper tee. It's installed exactly the same way as a taper tee, so you're still using the three-pronged. You turn it so that it engages in the slot, and then rattle it up. It does provide some clamping force, but it is not designed to provide the clamping force of a taper tee. And again, we have the wear sensor installed directly in a liner. So this is in any application that you like. As long as we have a 12mm pierced hole, we can pop our probe through. We can even retrofit them into applications that have already started wearing. We've done a fair bit of that in the Pilbara as well. The gateway and receiver details. This communicates wirelessly with the sensors. The batteries that we have in the sensors, we've done a lot of work on what we're asking the batteries to cope with. So each step of what we're asking the sensors to record, keep, and then send on to the gateway has been allocated a wattage, and that we know exactly how much we're drawing on the battery. And the minimum life we're getting out of our batteries is 5 years. The design life is 10 years. So the plug and play of the batteries it's not an issue. The gateways are IT stuff. It works. It's really, you can tell I'm not an IT person. It's very, very simple to operate. We have 3 different types of gateway receiver options. We have the full mine spec, the full mine spec cabinet that must be installed by an electrician. We also have the temporary gateway receiver, which just needs 24-volt power. And then we've also just recently developed this little GTAC rugged. All the site needs to do is wander out every couple of months. The little red dots in here go green when they've got information from the sensor. You can wander back and it's all done. So from really quite permanent and obviously more expensive in the permanent gateways to the portable receivers. And the portable receiver is also very good for trials. It's, you can hire one of those from us. And that will come with all the software and with your assets set up on it. So the user interface, which is the most important part really. So this is the fixed chute of that train loadout bin that I showed you before. And you can see you get to decide what turns green into yellow, what turns yellow into red, and what turns red into, oh my goodness, black. So we get a little exclamation marks when we perhaps haven't had a reading from a sensor, and so we can go and look at that. So right here, right now, we can see that this wall is probably what they should be concerned about. Maybe they should think about ordering some spares for that, ready for the next inspection. We can go down to individual sensor, or we can put them all on the map. They've done really well in the development of this, in that it is really streamlinable into whatever you want to see. Again, there's the little information about the battery. There's a few other things that the sensors can record that really just came with the sensor that we use, so we can set up what you actually want to see. Visual alerts, email notifications, all sorts of things are possible with the user interface. You can also drill down into that liner, and if you're monitoring these same asset across multiple campaigns of the liners, you can go back and see how long that liner lasted last time, compare it to this time, has something changed. It really provides quite a lot of really useful information. This is an installation example. It probably shows both things actually, how Taper T can work and then how WearSense can work. If you can see right there, this is the, oops, I've gone back. This is the slide face on the side of a bucket wheel. And this is it in graphical form. When it was first designed by those groovy design engineers, they put a bazillion 300 by 300 tiles all across the surface with 4 holes in every one. So we had to take out, put in 4 holes, 4 attachments for every liner. So the first thing we did, and it's very unusual for a fastener company to do this, is say you don't need that many fasteners. So we've reduced the number of fasteners, we've increased the size of the liners, and we've quartered the downtime. So that in itself is the value proposition for Taper T. The method works so quickly, so usefully, that your downtime is reduced. You can see here the positions. This is a trial that we've had ongoing for probably 5 campaigns. Initially, where we placed the sensors was where they were initially throwing, where the dirt trail was. But you can see this is the results of the latest campaign, and you can see that we're getting much more wear in this. So we're starting to think that they're either more or faster, so the velocity's increased, or we're getting more tonnage across the face, and so the wear pattern has moved from over here to over here. So we'll look at putting some more sensors in this portion of it in the next opportunity to do so. Yeah, that's probably all I need to say about that. We've had other applications, and in this application, this is an apron feeder. So we've actually put these in. You can imagine an apron feeder which sits under the stockpile. The stockpile's not removed very often. We've actually put these into the liners from the back while it's full, under operation. Well, not under operation, but not cleared out, which was another advantage of that. We had no trouble in this concrete underground bunker thing with the radio signals, so we're still getting good readings from all of our sensors. That's just a bit more on that same application. This is the photos of the train loadout bin. You can see on some of them we used taper tees, and on some we used huggers. In the train loadout, there's a lot of hydraulic arms and things that we need to stay out of the way of. We didn't really want our sensors smashed by them, so we put the low profile ones on the sides, and we put the ones where there was room to use the taper tee. So we can modify it to suit your application. This is an example of the forecasting that we give. So these are actual recording readings from the sensor to tell you how much WearPlate is left. And we can say that this is your forecast wear life. So the value proposition for WearSense, it's reducing maintenance downtime, it's reducing labour costs, and reducing inventory costs, because we saw from that train loadout application we really need to only look at that one face. The other three faces were actually performing quite well and may go another campaign. It improves safety, and it's applicable to all wear liner materials, and it's very easy to implement. Even a non-IT person can do it. So thank you very much.
Any questions for Cathy?
Yeah.
Cathy, the ones you called them easy, something of the three balls.
Yes, easy lock, yep.
Okay, you said that the balls are located on the outside with the pin that pushes the balls. I noticed on the diagram it seemed like the balls were inside of the ring.
The balls start off inside the ring.
And then do they go through the ring or just...
No, the ring, it just expands around the ball and contains it. You push the pin through and the ball bearings drop in, and then the ring drops off.
The ring drops off?
Yeah, so that's the other advantage of the taper tee, is it has nothing that drops off, whereas the easy locks actually have that ring drops off.
Any more questions? I've got one.
Yep.
Can you adapt it to mobile plant equipment?
We're looking at truck trays. The WearSense, we're definitely looking at truck trays. That's quite a big issue for them, and we have done a lot of issues on the impact and what the sensors can cope with. Okay. With the other ones we're looking at are crushers and things like that, because exactly the same.
Yeah. Okay. Thanks very much.